So going now to look through the National 5 paper 2, so the calculator paper from 2014. Right, so question 1, we've been told that there are 964 pupils on the roll at Aberleven High School. The forecast is that the roll will decrease by 15% per year. So what will the expected roll be after 3 years? And we've been asked to give the answer to the nearest 10. So the first thing we need to figure out is what percentage are left after a year. So the way that I do this is think of 100% as this box. So it's decreasing by 15%. So that means what's left is going to have to be 85%. So kind of the whole thing is the 100%, so what we kind of start with, and then we've got to find 85% of that. But then after that first year, we would need to, that now becomes our 100%. So we've got to find the 85% of that. And we could do this step after step going down, but there's a short method which we should all know. So what we have to do is turn our 85% into a decimal, which is 0.85, raise it to the power of how many years we're trying to find this after, so it would be to the power of 3, because we want to find it after 3 years, and then we have to times that by the original roll. And we're going to get that that is 592.0165. Okay, so we've been asked to round it to the nearest 10. So because 592 is closer to 590, so our answer would be 590 pupils. Right, so how this question is marked. So for the first mark, you get a mark for knowing to decrease by 15%, so the 0.85. You get a mark for knowing to times that cubed by 964, so knowing how to calculate the roll. And then you get a mark for the final answer rounded to the nearest 10. Okay, so it's quite a straightforward question, as long as you remember how to, the fact that you have to raise it to the power of the number of years. Okay, so now on to question 2. Right, so question 2, we have a box shows a cube placed on top of a cuboid relative to the coordinate axis. We've been told point A, and that's 8, 4, 6, and we need to write down the coordinates of B and C. So B and C. Okay, so the first things we kind of need to figure out are, have a think about what do we know about cuboids and what do we know about cubes. So we know that this point here, so my way of doing this would be to kind of mark all the coordinates that we know. So we know this one has to be 0, 0, 0, because it's at the origin. This point here, we know that that has just come along the x-axis. Nothing has changed with the y or the z. So we know that that one would be, the x is going to be the same as it is at A, so we have 8, 0, 0. Yeah. We know that this point here, so this corner, all that's changed from there is that it's gone along, and that's the y-axis away from us. It's gone there, and because it's in line, so it's gone 4. So we know that's going to be 8, 4, 0. And from here we're kind of figuring out a little bit more. So for looking at the cube now, so that's kind of going to help us a little bit in figuring out what we need. So here, going to this corner of this cube, what we know is that it's come the same distance up from this point as that one has come up from there. And that is in the z direction. So this point here, we've come up 6, so it's going to be 8, 0, 6. So we have 8, 0, 6 here. So we know that if we look at our cube, so we've got this point here now and this corner here. That's going in the y direction, and we know that our y coordinates changed from 0 to 4. And we know that cubes have the same, all of the sides are the same length. So we now know that each and every single side of this cube is 4 units in length. So we can use that to be able to calculate those coordinates that we've been asked for. So we know what A is, and we need what B is, and we need what C is. So if we start from A, we've gone 4 up, so that is the Z direction. So the Z needs to be increased by 4. So that means we're going to go, and it's going to be 8, 4, 10. Okay, so now we've got the B is 8, 4, 10. Let's have a look at what will be going on for finding C. So what's going to have happened is we're going to have come back along here to this coordinate here. So if we look at this one, we've come back along the y-axis 4. So that means that our y number is going to go down by 4, so that would be 8, 0, 10. And then, to go from there, across this way, we've come back across as the x-axis, so we've come 4 down the x-axis, so the x coordinate needs to go down 4. So that means we have 4, 0, 10, and that's us. So for this, it's a lot about kind of figuring out what we know, remembering that we know that cubes have all the sides the same length, and just having a little think about the information we've got. So knowing that we've got the origin, kind of working down from here, knowing that we've gone down the z-axis to 0, and being able to work out everything that's happening in the cube and the cuboid. Okay, so this question, you just get 1 mark for point B and 1 mark for point C. Okay, on to question 3. Right, on to question 3. We have 2 groups of people go to the theatre. Bill buys tickets for 5 adults and 3 children. The total cost of his ticket is £158.25. So we need to write down an equation to illustrate this information. So, if we say an adult is going to be A, and a child is going to be C, then we've got 5 adults and 3 children, and that is £158.25. Right, so for part B, we've got Ben buys tickets for 3 adults and 2 children. The total cost of his ticket is £98. Write down an equation to illustrate. So we have 3 adults, so 3A, and 2 children, so 2C, equals 98. Okay, so that's parts A and B done. So on to C. So it says calculate the cost of the ticket for an adult and the cost of the ticket for a child. So for part C, what we're doing is we are solving these equations simultaneously. So what we need to have is, with our 2 equations, we need to have either the A's or the B's having the same number in front of them. So at the minute we have 5A and we have 3A, and we've got 3C and we have 2C. So whatever we do, we're not going to have something that's going to help us to cancel this out, because if we subtract these equations now, we're going to get 2A plus C, and we're going to find that, but we're trying to find out what the A's are worth or what the C's are worth, so we need to make them equal. So one thing to do is we can look and we could think, well, if we multiply this top equation by 2 and the bottom equation by 3, then we are going to get 6C for both of these. So if we do that, we're going to get 10A plus 6C equals £316.50. So it's remembering that when you're multiplying by 2, it's the whole thing has to be multiplied by 2, every single part, the A's, the C's, and the what it's equal to. And then we times the bottom one by 3, we're going to get 9A plus 6C is equal to £294. Right, so now, to get these equations, we want our C's to go away, so we need to subtract them. So we have 10A take away 9A, so we just have A. We have 6C take away 6C, which is 0. At this stage, we should always be really careful and make sure that we actually follow this through. So 6C take away 6C. Whereas if we accidentally tried to add these, we'd go 6C add 6C is 12C, and we'd know that we'd made a mistake So I always find it important to put that 0 in there just as a reminder and a double check that that is actually what we've got. So we've actually managed to cancel it out and we've not done made a mistake. And when we do this, we subtract it, so we're going to get 50, we're going to get 2, and we're going to get 2. So it's going to be an adult costs £22.50. Okay, so now that we've got the cost of an adult, we need to find the cost of a child. So we can substitute this adult cost back into one of our original equations, so into one of these two. I'm going to use equation C. So if we use equation C, we have 3a plus 2c equals 98. So if we replace the a with the £22.50, then 3 times that £22.50 is going to give us £67.50, which is equal to 98. So then we're going to get that 2c is equal to £30.50. So then that means that C is £15.25. Right, so the marks for this question. You get 1 mark for your equation in A, 1 mark for the equation in B. You get 1 mark for showing that you've scaled your equations, so multiplied them up so that your C's or your A's are the same coefficient, so the same number in front of them. You get a mark for following a strategy to find your A and B, and then you get a mark for finding the correct A and C. And then there's actually a mark that at this point you wouldn't have got. So you need, because it says the cost of the ticket, we need to communicate them in money. So we need to write an adult ticket costs £22.50 and a child ticket costs £15.25. And that is where you get your last mark. So because it's been asked about money, you need to put your answers in money to get that mark. Okay, so going on, we will move to question 4. Right, so question 4. This is our mean and standard deviation question, so we can give in times for laps, and we need to calculate for part AI the mean of these values. So we know that the mean can be written as x with that little line above it, and what we need to do is we need to add together all of our values. So just copying each of them down, and then we divide it by how many values we have. So we've got 1, 2, 3, 4, 5, 6, so we're dividing it by 6. Note here in the question, they have really in bold written, actually for all parts of it, something that's really important, and we need to be doing that every single time. So if it says to clearly show you're working, every single time you need to be doing this. You need to be doing every time what the question asks you to do. So at this point it's safest to then add up your top line. When we put them into the calculator we get 339, and then we're dividing that by 6, which gives us our mean, which is 56.5. Right, so for part 2 we have our standard deviation. So we've been asked to calculate standard deviation, and again it says clearly show all of your working. So we need to be reading the question and making sure that we're following exactly what the instructions say. So the method I'm going to use is using this equation here. So the equation that is the sum of x squared minus the sum of x all squared over n divided by n minus 1. So before we can use the equation we need to find our values of x squared and the sum of x and the sum of x squared. So our x's are just our values, so we've got 53, 57, 58, 60, 55 and 56. We know from part A that they add up to 339. Now we've got to square them, and we get, so for 53 we get, when we square that, we get 2,809. When we square 57 we get 3,249. When we square 58 we get 3,364. When we square 60 we get 3,600. When we square 55 we get 3,025. And then when we square 56 we get 3,136. And then when we add those all up in our calculators we get 19,183. Okay, so we've now got those, so we can put these into our equation. So we know that the sum of x squared, so that's the 19,183, and then we're subtracting 339 squared over 6, and then our n minus 1 is going to be 5. Okay, so when we put those into our calculators, we get 2.42899, and then it keeps going. Right, so round that, so put it as 2.43 to 2 decimal places. Right, so we now have to look at part B. So we've been asked, and we've been told that she's changed her training routine, hoping to improve her consistency. After the change, she records her time for another 6 laps. The mean is 55 seconds, and the standard deviation is 3.2 seconds. Has the new training routine improved her consistency? We have to give a reason for your answer. Okay, so we need to know what is actually telling us about the consistency. And the consistency, the thing that tells us about how consistent something is the standard deviation. So the lower the standard deviation, the more consistent the values are. So we can see that we found that her standard deviation for the first 6 laps was 2.43, and then it becomes 3.2, so it's increased. So that means the consistency has not increased. So we can say her consistency has not increased as the standard deviation is higher. Or as the new standard deviation is higher. Right, so thinking about the marks for this question. Right, so for part A, you get your 1 mark is for having the mean calculated. And then for part 2, so A part 2, you get 1 mark for calculating your sum of x and x squared, 1 for substituting it into the formula, and 1 for your answer. And then for here, for part B, her consistency has not increased as the new standard deviation is higher, or anything saying no, the standard deviation is greater, the times are more spread out. Just a good explanation of what's happened because the standard deviation is increased will get you that mark. Right, on to question 5. Right, so question 5, looking through this. So we've been told a supermarket sells cylindrical cookie jars which are mathematically similar, and that mathematically similar is the bit that's really important. Okay, so the smaller jar has a height of 15 centimeters and a volume of 750 cubic centimeters. So I'm just going to write that on. And our large jar has a height of 24 and we need to find that, so that's unknown. So the first thing we need to do is, this is similar shapes, so we need to find our linear scale factor. So because we are going from, we're trying to find something on the bigger jar, we need to find how it increases. So it's going to be our larger number divided by our smaller one, because it's an enlargement scale factor. So it's going to be 24 over 15. So then to find the volume scale factor, because we know the volume, and so that's what we're trying to find out about, we need to cube our linear scale factor. The way I quite like to think about this is if you remember that volume is centimeters cubed, So that means for the volume scale factor, you need to cube the linear scale factor. Because the linear scale factor is in centimetres, the volume scale factor is centimetres cubed. So the difference is a cubed, so you've got to cube it. So now to find the volume, we have to take that volume scale factor, we need to cube it, and then we times it by the volume of the smaller tin. And we are going to get that the volume of the larger jar is 3072 centimetres cubed. Right, so that one's quite a straightforward question as long as you remember that you have to cube your volumes to get your volume scale factor. So the marks for this question, you get 1 for the linear scale factor, 1 for the volume scale factor, so knowing to cube, and then 1 for your answer. So on to question 6. Right, okay, so for question 6, we have a diagram below that shows the positions of 3 towns. Lowtown is due west of Midtown. Okay, so that's saying that is straight that direction. And we've been told the distance from Lowtown to Midtown, which is 75 kilometres. We've been told that Midtown to Hightown is 110 kilometres, and we've been told that Hightown to Lowtown is 85 kilometres. And we've been asked, is Hightown directly north of Lowtown? So that's the important part of this. So that's the bit we kind of need, is this bit here. Is Hightown directly north of Lowtown? Okay, so now for this, what we're looking at is, if it is directly north, then this in here will be a right angle, because that's west, and we know that between west and north is 90 degrees. So how are we going to prove, or otherwise, that that's a right angle? And that's got to be the converse of Pythagoras. Right, so then we have to do 110 squared, which is equal to 12,100. Okay, and then the shorter two sides, so we've got to find out what 75 squared plus 85 squared is. Okay, so that is going to be 75 times 75 is 5,625, which is 75 squared, and 85 squared is 7,225. So when we add those together, we get 12,850. Right, so because those aren't equal, that means this isn't a right angle triangle. Okay, so we need to justify our answer. Right, so we can say this is, justify your answer means write me a sentence, please. Right, so therefore the triangle is not right angled as c squared does not equal a squared plus b squared. Okay, and then that's not actually answering the question quite yet. We then use that to say because it's not right angled, that means that Hightown is not directly north of Lowtown. So, as the triangle is not right angled, Hightown cannot be directly north of Lowtown. Right, so marks for this question come from 1 mark for picking to use the converse of Pythagoras. So, kind of, for example, doing this first part here, just knowing to do the 110 squared and the 75 squared plus the 85 squared is 1 mark. You get 1 mark for getting the answers for those two, so both the 12,100 and the 12,850, that gets you your second mark. You get 1 mark for making a comparison, so saying that they're not equal, and then 1 for saying no because it's not a right angled triangle. Right, okay, so next question. Okay, so for question 7, we have an ornament is in the shape of a cone with diameter 8 centimeters and a height 5 centimeters. The bottom contains a hemisphere made of copper with diameter for 7.4 centimeters, and the rest is made of glass as shown below. Calculate the volume of the glass part of the ornament, giving your answer correct to 2 significant figures. Right, so first thing we need to do for this is find the volume of the cone. So the volume of a cone is equal to 1/3 pi r squared h. Okay, so we have 1/3 times pi times the radius of the cone. Okay, so we're given 8 centimeters, which is the diameter. So to find the radius, we have to half it. So that's 4 squared, and then the height is 15 centimeters, which gives us a volume of 251.32 centimeters cubed, if we round it. Okay, so that's the volume of the cone. So now we need to find the volume of the hemisphere. Knowing that a hemisphere is half of a sphere, first we find the volume of the sphere and then we half it. So the volume of the sphere is equal to 4/3 pi r cubed. Okay, so we've got 4/3 times pi times, again it's the radius we need and we have the diameter, so we've got to half the 7.4, which gives us 3.7. Okay, so we've got 4/3 times pi times 3.7 cubed, which is going to give us 212.17, and that's centimeters cubed. Okay, so the volume of the hemisphere is a half times 212.17. Okay, so we get 106.087. Right, okay, so the volume of the glass is going to be equal to that 251.32. Take away the volume of the hemisphere, so 106.087, which gives us 145.233 centimeters cubed. So therefore it's going to be 150 centimeters cubed to the 2 significant figures that they asked for. Okay, so the marks for this question come for successfully substituting into the volume of the cone, successfully substituting into the volume of a sphere. You get for knowing to subtract the volume of a hemisphere, so you have to have done the hemisphere bit to get this 3rd mark. 4th mark is to get that answer correctly, and then your rounding gets you your 5th mark for this question. Right, so question 8, we have an algebraic fraction that we need to simplify, so we have n to the power of 5 times by 10n over 2n squared. So the first thing we need to do is we need to work with the indices on the top. So when we have indices that are multiplying, that means that we need to add the powers. So n on its own is just n to the power of 1. So we add the powers. So the number just stays the same because there's not any other number to multiply it by. And then we have n, and it's going to be to the 5 plus 1, so n to the 6 over 2n to the 2. So at this point, my next thing to do would be sort out the powers from top to bottom. So when powers are dividing, we have to subtract them. So we have 10 and the 2 is still there. And then we've got n, and then it's going to be 6 take away 2, so that's 4. And then the last thing we need to do is sort out our numbers. So we have 10 on the top and 2 on the bottom. So that's 10 divided by 2, so that's just 5. And it's n to the power of 4. So for this question, your marks come for simplifying the powers in the numerator. You get a mark for eliminating n from your denominator, so just moving it all onto the top. And then your last and third mark is for cancelling constants, so just the numbers and getting the 5. On to question 9. Okay, so question 9, we have to express 7 over x plus 5, take away 3 over x as a single fraction in its simplest form. Right, so where we're going to start is when we're adding or subtracting any fraction, doesn't matter whether it's an algebraic fraction or a normal fraction, we need to have a common denominator. So that's where we need to start. So for this one, the way to get our common denominator is to multiply the two denominators together. So we have 7 over x plus 5, take away 3 over x. Right, so for our common denominator, we're going to have x plus 5 as the common denominator. So we're multiplying those two together, two denominators, right? So for the first side, when we've taken x plus 5 and we've changed it to that, right? This is just, I'm doing the red as kind of some extra explanation. So x plus 5, what we've done is we've times it by x to get x times x plus 5. So whatever we do to the bottom of our fraction, so we times the bottom of our fraction by x, so we have to times the top of our fraction by the same thing. So when we times 7 by x, we get 7x. Right, so the other side, again, using the arrows just as a kind of guide, to go from having x to having x times x plus 5, we've had to multiply by that bracket x plus 5. So what we do to the bottom, we have to do to the top. So when we multiply that, we get 3 times x plus 5. Right, just going over that quickly. So now we need to multiply out our brackets on our second fraction. So leave the first one as it is for now. And then we're going to have the bottom of our fraction here. So we've got x plus 5. And then we have 3 times x, which is 3x. And 3 times 5, which is 15. Right, so now we're combining it into one fraction. So because our denominators are the same, we can just combine the top two bits. So we get 7x, and then we're taking away this whole second bit. This is where we need to be careful, because otherwise our signs are going to be wrong and we're going to get a mistake. So then we get 7x. That's like minus 1 times that bracket. So minus 1 times that. So minus 1 times 3x minus 3x minus 1 times 15 minus 15 all over x plus 5. So 7x take away 3x is 4x. Take away 15, nothing else we can do with that. All over x bracket x plus 5. Is there anything else we can do here? There's no common factors we could take out of the top. There's nothing else, so that is us. That is us at our simplest form. And the marks for this question come from 1 for the x bracket x plus 5, so having the common denominator. 1 for having a consistent, so bring it into one fraction. And then 1 for simplifying, so that question is worth 3 marks. Okay, so question 10. In a race, boats sail around 3 buoys represented by A, B and C in the diagram below. B is 8 kilometers from A on a bearing of 060 degrees. C is 11 kilometers from B, A is 13 kilometers from C. So we have to find the size of the angle ABC. Okay, so when we look at this, we have a triangle. So when we see a triangle, there's three things it could be. It could be Pythagoras, it could be SOHCAHTOA, or it could be the sine and cosine rules. Okay? We don't have a right angle, so that rules out everything but the sine and cosine rules. So it could be the sine rule or it could be the cosine rule. How do we know which to use? If we've been given all three sides, like we have here, then it's going to be the cosine rule. Okay, so we need the cosine rule, which is that the cos of an angle A is equal to B squared plus C squared minus A squared over 2BC. Okay, so the angle we want to find, at this point, this is where I start, I would suggest just ignore the kind of letters on the diagram for now, put them back in at the end, so the angle we want is A, so B, this now becomes A, because that's the one we want, angle ABC, it's the angle at B, so this becomes A. We can leave C as it is, and then we can make that B. Okay, so this means that we're not changing anything around in our formula, we're just putting it in this way. Okay, so that we get the cos of that angle A is equal to 11 squared plus 8 squared minus 13 squared over 2 times 11 times 8. Okay, so when we put that into our calculators, we get cos A is equal to 0.090909. Okay, so A is equal to the inverse cos of that. So because to get rid of the cos, we need to do the inverse. Try not to round at this point because it can create some errors. So like in your calculator, use the answer button rather than typing it in. So we get 84.78 degrees to 2 decimal places. Okay, so this is the point where you go, therefore, angle ABC is equal to 84.78 degrees. So you go at the end and you say that you know that that is angle ABC. Also, as long as you've kind of drawn on your diagram that you've changed it, the angle, like the letters and stuff, it's not a big deal, okay? Right, so that was part A. So for part B, we need to find the size of the shaded angle. Right, so here, one of the things that we should know is that a C angle, so if you've got, I'm going to redraw this down here so it's a little bit easier to see. So we've got this is 60 degrees in here. We've got that one going off there. We know this is 84.78 degrees. Okay, and this bit in here is what we want to find. Right, so when you have angles like that, like a C, this angle in here and the 60 degrees have to add up to 180, so that makes that have to be 120 degrees. That is because if we had these like this, and I can draw this down, we have our 60 in here, and if it just looked like that, that would be 60 in there because it's a Z angle, and then you've got a straight angle which adds up to 120, which is another way to see where that 120 comes from. Okay, so the shaded angle is going to be equal to 360 because it's a full turn that these all add up to. Take away the 120, take away the 84.78, which gives you 155.22 degrees. Right, so the marks for this question, you get one for correctly substituting into the cosine rule, one for finding what the cos of the angle is equal to, and then one for calculating the angle correctly. And then for part B, you get 1 for knowing how to calculate the angle, so to subtract, and then 1 for getting the answer. Okay, on to the next question. Okay, so we are going to change the subject of the formula, and the formula is S equals ut plus a half at squared, and what we've got to get it to is a. Right, so the first thing we need to do is get the term with the a on it on its own, so we're going to have to take away ut from both sides to get rid of that, so we end up with S take away ut equals a half at squared. Okay, now we're trying to get the a on its own, so the first thing to do is to get rid of the fraction. So we're going to times by 2 to both sides, and remember we have to times all the terms by 2. So we're going to get, we can either do a 2 outside a bracket or we can times each term by 2, it's fine either way. I'm going to put a 2 outside a bracket, so it's 2 times by s minus ut, because that whole side has to be times by 2. And that gets rid of our half, so we get at squared. And then to get rid of the t squared, to get the a on its own, that's a times by t squared, so we have to divide by t squared to move it to the other side. So that gives us that a is equal to 2 s minus ut all over t squared. Okay, and the marks for this come from, pretty simply for this one, it's 1 mark for subtracting the ut, 1 mark for timesing by 2, and then 1 mark for dividing by the t squared. So that is question 11. Okay, so this one should be fairly straightforward. So we've got 11 cos x minus 2 equals 3, and we need to solve between 0 and 360. So first thing to do is to rearrange. So we're going to add 2 to both sides to give us 11 cos x equals 5. Okay, and then we have to divide both sides by 11 to get rid of the 11 in front of the cos to give us cos x equals 5 over 11. Okay, so at this point we draw our cast diagram, okay, which helps us to figure out which 2 quadrants this is going to be in. So because cos is positive, that means it's going to be in the first and the last quadrant, the first 4. So if we find our relative acute angle, that is just the inverse cos of 5 over 11, and this gives us the angle in that first quadrant. Okay, and you always put the positive of the fraction in here. Even if you've got a negative, you always put the positive in to find your relative acute angle, which in this case is 62.96 degrees to 2 decimal places. Okay, so here we have x equals cos to the minus 1 of 5 over 11. Okay, so one of our answers, because we're in the first quadrant, is just going to be that relative acute angle, which is 62.96. But our second angle is in our fourth quadrant, and to find that it's 360 take away that relative acute angle. So we're going to have 360 take away 62.96. So we have 62.96, and we also have 360 take away 62.96, which gives us 297.04 degrees. Okay, so those are our 2 values for x for this question. Okay, so the marks for this one, 3 marks. We get 1 for rearranging to cos x equals 5 over 11. Your second mark is for getting the first angle of 62.96, and the third mark is for getting the 297.04. Okay, so hopefully that was straightforward, and then on to our last question for this paper. Okay, so we've got the picture shows the entrance of a tunnel which is in the shape of part of a circle. The diagram below represents a cross-section of the tunnel. The centre of the circle is 0 or O. MN is the chord of the circle. Angle MON is 50, and the radius of the circle is 7 meters. And we've got to calculate the cross-section of the tunnel. Okay, so the way we're going to do this is we're going to split it up into 2 different steps. Don't try and do the whole thing all at once. Split it up. So if we first look at this section here, we have a triangle. So if we just draw the triangle out separately on its own, okay, so we've got 7 meters, 7 meters, and we've got 50 degrees. Okay, so we need to find the area of that triangle. So we have the formula, the area equals a half AB sine C. And that works perfectly because our angle is right in the middle of those two. So we have a half times 7 times 7 times the sine of 50, which gives us 18.77 meters squared. Okay, so we found that area. We need to find now the second part, the second area here. So if we kind of draw that out separately as well, we have a sector where we've got that as 7 centimeters, that's 7 centimeters, but this angle in here is now had to be 310 because it's got to add up to 360. So the area of the sector is equal to, this formula you need to remember, it's x over 360 times by pi r squared. Okay, so you're finding a fraction of the circle, and the fraction is from the angle of the circle, and then you're timesing it by the whole area because you're only finding part of the area. So the angle is 310 over 360 times pi times 7 squared, which gives us 132.56 meters squared. Okay, so then we have to find the total. So the area total is equal to 132.56 plus that 18.77, because we've got those two, we need to combine them into one. So we add those two together, the 132.56 and the 18.77, which gives us 151.33 meters squared. Okay, so I think the hardest bit in this question is figuring out what to do, but if you kind of take it step by step, it's not too bad. Okay, so the marks for this question come from 1 for the evidence of showing that you're adding the two totals together, 1 for being able to find the fraction of the circle, 1 for knowing how to find the area of the sector, 1 for knowing how to calculate the angle of the triangle, and then 1 for calculating it all out correctly and getting the answer. Okay, so hopefully this has been helpful. This has been the 2014 paper 2 for National 5. If you've got any questions, please leave a comment. There's also multiple ways to do question 13. There's other ways, but I think this is the most simple way. But if you've got any questions, if you've tried it a different way, let me know. Thank you for watching. Like, comment and subscribe, please.